So 4.3 is all about factoring quadratics, specifically when the leading coefficient is 1. Now, why do we study factoring? Why do we need to know how to factor quadratics? Well, factoring is a very, very powerful technique that allows you to do a lot of cool math stuff. It allows you to solve a lot of problems. And how does it allow us to solve problems? Well, we're going to utilize one very important theorem in the world of mathematics. As a matter of fact, we did use it yesterday. I just didn't draw any attention to it. We sort of subtly, indirectly used it. That important theorem is called the zero product property. And although it has its own fancy special name, it's actually a very straightforward idea that I'm pretty certain that you've learned in grade school when you learned your times tables. The zero product property states, if two numbers multiply together to equal 0, then at least one of those numbers must equal 0. So I hope in grade school your teacher always told you, oh, anything times 0 is 0. Well, the zero product property sort of takes that viewpoint in reverse. If the answer of a multiplication problem is 0, then at least one of those numbers had to be 0. You had to have multiplied by 0 some point in time. Symbolically, what it says is, if two things multiply, say capital A and capital B, if they multiply together and they equal 0, then either the first guy, A, equals 0, or the second guy, B, has to equal 0. And that's what we did yesterday, right? We had factored form or intercept form, 2x minus 3x plus 4 equals 0. And we were finding the x-intercepts by, well, setting each separate parentheses to 0. We did 2x minus 3 equals 0. We did x plus 4 equals 0, and then we solved those two equations separately. Let's work on the left equation. We're going to add 3 to both sides, and then divide both sides by 2, so we get 3 halves. Working the right equation, we're going to subtract both sides by 4, and you get these two answers here. So that's how we solved for the x-intercepts yesterday when the equation gave us a factored form. So today is all about, well, what if they don't give it us in factored form? What if they give it to us in standard form and we had to factorize? Well, we just have to exploit a relationship between factored form and standard form. So this is the relationship between factored form and standard form. So if we had standard form here, ax squared plus bx plus c, and I want to see what would happen if it equals factored form, two parentheses, this is sort of the idea. Whatever you put in these first slots has to multiply to the first term here, this entire guy. Whatever you put in the second slot has to multiply to the last number in your standard form. The only other part of the standard form that we seem to be neglecting is the bx, the middle here. Well, what happens is once you figure out the yellow pieces and once you figure out the pink pieces, you just have to, your middle term is sort of like a check. When you multiply these guys out, do FOIL, do repeated distribution, it has to combine into the middle piece. If it does, you're correct. If not, you did something wrong. I hate to put it, but this is a topic where it's sort of you either know it or you don't know it. It's one of those math topics where it's so simple that the hardness, the difficulty is your knowledge of times table, is your common sense, it's your logic. So if we are not good at factoring, we just have to practice a lot. Now, there is no formula to do this. There is no one way to do this, but I do have some hints, suggestions, technique that might help you out. So if you know you struggle with factoring, let's listen up. Today, we're only going to look at the easy cases when the leading coefficient is 1. Tomorrow, we'll look at the harder cases. So for example, suppose I ask you to factor x squared plus 17x plus 60. Well, this is the idea. If this guy is factorable, we know that the answer should be 2 parentheses. And we also know that whatever we put in the first slot has to multiply to the first term. Well, since the first term is always going to be a simple variable squared, an x squared, there's only one way I can multiply two things and get x squared. It's simply x and x. Right? So that part should always be simple. If the leading coefficient is 1, if you don't see a number from the x squared, it's going to be variable at the beginning. Now here's my strategy or technique. You're going to go ahead and look at the very last number and do something that I like to call pairwise factor. So you write the number on the side, this is scratch work, and you're going to find every single pair of numbers that multiply to it. Now I do this a systematic way. Don't just wildly guess and go out of order because you might miss one. This is the way I do it. I always start with 1 in the number because I always know 1 times a number is itself. And then I increase from 1 to 2. I just go in order. 1 to 2, 2 to 3, 3 to 4. And I just ask myself, do these numbers divide evenly and nicely into, in this case, 60? Now, I'm pretty good with times tables, so I do it in my head. But if you're not good at your times tables by now, just use a calculator. So I'm going to use my pretend calculator here and go, okay, I already did 1. Let's move on to 2. Does 2 divide into 60 evenly? Does it give me a whole number when I divide? So I type into my calculator 60 divided by 2, and it gives me a whole number, 2 and 30. Move up from 2 to 3. Take out my calculator, 60 divided by 3. Oh, that gives me a whole number, 3 and 20. Move up to 4. 60 divided by 4 gives me a whole number, 4 and 15. 60 divided by 5 gives me a whole number, 5 and 12. 60 divided by 6 gives me a whole number, 6 and 10. 60 divided by 7 gives me a decimal number, so skip them. 60 divided by 8, decimal, skip. 60 divided by 9, decimal, skip. The next number I would test would be 10, but notice I've already written down 10 here. So the idea is you can stop with your list when you reach a number you've already written. So I would have to guess 10 next, or check and divide by 10, but since I've already written down 10 here, I'm good. Okay. So once I have my complete list, how do I factor? Next, you want to look at the very last symbol here. This symbol will tell you to think, add, or subtract. Very obvious. If it's a plus, we think of add. If it's subtract, if it's a minus, we think subtract. What are we adding, subtracting? You're going to want to look at these pairs of numbers together. And you're going to ask yourself, which pair, 1 and 60, 2 and 30, 3 and 20, which pair will add or subtract to the middle number of 17? Positive or negative, I don't really care right now. I want to know which pair adds to a 17. So I hope it doesn't take a lot of thinking. Just look at the pairs together and add which one adds to 17. I hope everyone agrees that 5 and 12 adds to 17. So that tells me 5 and 12 go here. The last thing you want to do is figure out the pluses and minuses, because we know in these spots here I either have to put a plus or a minus. To do that, I'd like to sort of write these numbers separate. And then now I go ahead and figure out if it's positive or negative. So in this case, it should be a plus 17. So think of this as sort of a game. In these spots here, you can put a plus or a minus. You can make them both pluses. You can make them both minuses. You can make one a plus, one a minus. one a minus, the other a plus. You can do anything you want. I don't care as long as it's a true statement. So it's a puzzle. You got to figure out a 5 and a 12. How would I make a positive 17? I hope in this case it's very obvious that they both need to be plus and plus, because a plus 5 with a plus 12 will give me a plus 17. Guess what? Those are your symbols, and that is your factored form. So this topic is one of those, you just got to practice it. You just got to know it. There's no formula to follow. There's no calculations to do other than pairwise factors. It's just break down the factors of the last number, figure out what pair adds or subtract to the middle number. Let's take for this video. I mean, if you feel like you have a good grasp on it, just go ahead and jump into the practice. But I'm gonna add a handful of more examples just so you have more examples, and I'm going to talk through my thought process so you can see what I'm thinking when I'm doing these problems. So hopefully these are the same thoughts you should be having. Suppose I ask you to factorize x squared minus 22x plus 72. So the first thing I do is 2 parentheses. Since the first guy is just a regular x squared, I know it's going to be x and x. My last numbers is 72, so I'm going to pairwise factor 72. And if I'm not good with my times tables, I'm just going to take a calculator. Always start with 1 in the number and move up to 2. Does 2 divide into 72? Yes, he does. 2 and 36. What about 3? 72 divided by 3. That works. 3 and 24. What about 4? 72 divided by 4. That works. 4 and 18. What about 5? 72 divided by 5 is a decimal. Skip it. Move up to 6. 72 divided by 6, that works. 6 and 12. 72 divided by 7 doesn't work. 72 divided by 8 works, gives me a 9. The next number I would guess would be a 9, but since I've already written him down, I can stop. Next, I'm going to look at the very last symbol. The very last symbol makes me think of plus, add. So I'm going to ask myself, which pair adds to the number of 22? 1 plus 72? Nope. 2 plus 36? Nope. Hopefully you get the idea that it's going to be 4 and 18 because those guys add up to 22. So I'll write them down. Now I'll put the 4 and the 18 by itself equals, and it has to equal the symbol. In this case, it has to equal negative 22. So all you have to do is play with the pluses and minuses. Plus and minus, minus and plus, guess and check. Make sure you put the positives and negatives so that this is a true statement. And in this instance, they should be both negative because a negative 4 with a minus 18 makes a negative 22. So this is the factored form. Let's do one more example here just so I can showcase my logic. Oh, I don't know. Let's do example. Let's go ahead and factorize. What would be a good one to use? Might be big numbers, but we can handle it. X squares plus 47, x is minus 150. First things first, 2 parentheses. Since it's just a regular x squared, I know it's going to be x and x. Pairwise factor 150. I hope you get the idea by now, so I'm just going to fast forward through the list. I'm not going to talk through the dividing. 2 and 75, 3 and 50. I don't think 4 works. Nope, 5 will definitely work. 6 doesn't. Oh, actually, 6 does. 6 and 25, huh? 7 doesn't. That I'm for certain. What about 8? Nope. What about 9 doesn't? 10 does. 10 and 15. 11 doesn't. 12 doesn't. 13, 14. So this should be the whole list. Then you look at the last symbol. In this case, it's a minus. I'm going to think of subtract. Which pair subtracts to the middle number 47? 47, 47. Here we go. These guys subtract together to give you 47. 3 and 50. Now we just have to ask yourself, What do the symbols have to be in order to make a positive 47? And feel free to pause the video if you want to try it on your own before revealing the answer. But if you got it correctly, it should be a negative 3 with a positive 50. That will give you a positive 47 in the middle. Now, there are special exceptions to factoring. So far, we've been factoring quadratic trinomials, 3 pieces. There is a special factoring pattern if I only give you 2 pieces, an x squared and a constant. This special factoring pattern, which we must know, special pattern, is called the difference of 2 perfect squares. And the special factoring pattern says, if you have 2 pieces and they're perfect squares, a squared minus b squared, and you can always factorize them instantly without a lot of thinking into a minus b, a plus b. Now, what is a squared? What is a, b? This is so confusing. You just have to remember the relationship. If I have a squared and I want to go to a regular a, what math thing would I have to do to go from an a squared to an a? Well, I hope everyone can see that that's just a square root. What would I have to do to go from a b squared to a b? Hopefully everyone can see that it's just a square root. So the difference of 2 perfect square pattern simply says if you have 2 perfect squares and they're subtracting each other, you shouldn't have to do a lot of thinking. It will always factorize into square root minus square root, and then the other parentheses will be plus. So if I give you something like this, factor x squared minus 25, right? That looks really weird. Oh, it's only 2 pieces. All the other examples have always been 3 pieces. 3 pieces here. 3 pieces here. So if I ask you to factor and it's only 2 pieces, you think of the special factoring pattern. Is this a perfect square? Yes. Is this a perfect square? Yes. So then it should factorize into the above pattern. What's the square root of x squared? Oh, that's just x. Minus, what's the square root of 25? Oh, that's just 5. And then the other parentheses will simply be the plus. Easy peasy. We factored it. We're done. So these special factoring patterns should be super duper easy, fast problems. Say I ask you to factorize, heck, I can even put numbers in front. 4x squared minus 81. Oh, it's 2 pieces. So 2 parentheses, are they perfect squares? Yes and yes. So now all I have to do is take square roots. What is the square root of 4x squared? Well, that's just 2x. What is the square root of 81? Well, that's just 9. One will be a minus, the other will be a plus. Heck, I can even try to make it look super scary with so many variables. What if I asked you to factor 9x squared y to the 4 minus w squared? Oh no, I can't do this. This is so hard. It's so crazy. Not really. I give you 2 pieces. So if he's factorable, he should be that special pattern. And then just take square roots. What is the square root of 9x squared y to the 4th? You just have to take it one piece at a time. The square root of 9 is a 3. The square root of x squared is an x. And the square root of y to the 4 is y squared. What is the square root of w squared? Well, that's just a w. And then, of course, one will be a minus, and the other will be a plus. You can see how this special factoring pattern is going to be very, very helpful for us when it comes time to factor. Now, again, why do we talk about factoring? We talk about factoring because it allows us to solve equations, right? And that's the whole point, to solve equations. Now, we solve equations because we can use the zero product property. This is sort of my last tidbit, my last tip here. To solve quadratics by factoring, the equation must equal 0 first. If that is not true, you might have to do a little bit of rewriting. For example, what if I ask you to solve, not factor? Notice the instruction doesn't say factor, it says solve. What if I ask you to solve, let's see here, let's find a good example. Solve 2x squares plus 5x's minus 20 equals x squares plus 28x's, not 28, let's do 23, no, let's do 18, that's a smaller number, 18x's plus 70. Whew, boy, that looks like a big problem. Well, notice, here's the left side of the equation, here's the right side of the equation. None of them equals 0. So I can't even solve this by factoring yet because I don't have a 0. So the first thing we want to do is move everything onto one side. I'd like the x squared to be positive, so let's move things to the left. I'm going to subtract an x squared from both sides. Let's see if we can do 3 steps at once. I'm going to subtract an 18. Actually, to make this problem work, guys, sorry, my bad. I'm going to have to do a little bit of erasing. Let's go ahead and make... No, 18 will work. Sorry, ignore me. Let's subtract 18 from both sides. And then let's go ahead and subtract 70 from both sides. Sorry, guys, that's been a long night. So if we can do 3 steps at once, because I want to literally move everything over to one side, so that's why I got rid of everything. We're left with x squared minus 13x's minus 90 equals 0. So this is good. This is what we want. We want equals 0. So the moment you have equals 0, you can go ahead and try to factor. Well, since it's just a regular x squared, it's going to be an x and x. Last number is a 90. I don't care if that it's minus, just that it's 90. So 1 and 90. I'm going to make this list quickly because hopefully by now you have some good understanding about it. 2 and 45, 3 and 30, 4 doesn't work, 5 and 18, 6 and I want to say 15, yeah, 6 and 15, 7 doesn't, 8 doesn't, 9 and 10, and then the very next number would be 10, but I already have them here. The last number makes me think of subtract. So which pairs of numbers subtracts to a 13? That would be 5 and 18. And it needs to be a negative 13. So that would be a positive 5, negative 18. So if the instruction said factor, this would be my answer. You just leave it as that. But since the instruction said solve, we're going to go ahead and do one extra step, the zero product property, and set each piece equal to 0. So now it should be easy, super duper easy to solve. X equals negative 5 and x equals 18. That is what I would submit for full credit. So just please be extra careful. If the instruction says factor, don't solve it, because if you do, I'm going to mark you off wrong. If the instruction says solve, go ahead and go all the way through and solve. If you just factor, that's incorrect. I'm going to mark it off as wrong. But that's it. That is 4.3, factoring when the leading coefficient is 1. It's a very good skill to have. It's a very good skill to know. So go ahead and give it a shot. Practice it.